So I hope what you learn is that when you do try to convince people, there's several things you must observe. One is that at the end you have to arrive at the conclusion, desired conclusion. Right? But more importantly is, in getting to the end, there's no way you can just get to the end without using in a critical way the given assumption that A is less than B. You have to remember, this is your given. This is your capital. This is your capital that allows you to make investment to make billions. That's what this is. Now this is in a microcosm, this is exactly all of mathematics. I give you an assumption, you derive a conclusion. You want to know what mathematics is? I mean, in a technical sense, that's all there is. Moving from an assumption to a conclusion by use of logic. And you want to cultivate this ability in all students. And if they can do that, you can tell yourself with great satisfaction that they have learned mathematics. Mathematics is basically the logical training ground for students to learn how to make deductions, to think logically. And if you don't think that's important, well, look at what's happening in Congress. Arguments are given without regard to assumption. Just left and right, just arguing randomly. They don't think straight. So, all right. So this is now. Oh yeah, but well, yes. So now in general we do better, right? Suppose I have two fractions, two arbitrary fractions. Suppose I know this is 2. What can I say about the number M and KL? As the other, okay, let's see what this would say. So what you're saying is that this is MA, this is KL, right? So it's the given fact is that the position is clear. M over N is to the left of K over L. But what I'm asking you is, yes, that's the given positions of the two points, but can you say something about the individual numerators and denominators? See, for example, right, this one, 27 over 31, huh? And then 18 over 22. Which is bigger? Decide. Or better yet, maybe that I should rather tell you, given two fractions, how you decide which is bigger. Maybe that's a better way to formulate it. Okay, suppose I put this in suspense, and I should say, okay, you decide, which is bigger? Now, this is one of the so-called, one of the educators' battle cry and say, children cannot compare and they don't understand fractions. You know that? Children cannot compare the fractions. Right? Why can they not compare? Well, have they been taught the right thing? So let's try this. How do you compare? How do you compare?
Make them equivalent.
Okay, now you're getting the hang of it, right? You've been drummed into you that the trouble is that you have different denominators. It's very hard to think about fractions with the different denominators. But knowing the equivalent fractions, you don't need ever to think about fractions with different denominators, because it has been handed to you on a silver platter. You see those, you change them at will, right? So you change that at will. You change it immediately to 31 times 22, and then this one also 31 times 22, right? That's the sort of sight unseen. I'm going to write that down. All right, now, this, from here to here, what do?
27 times 20.
Multiply, this is cos for multiply top and bottom by the same number, 22, right? Okay, so 27 times 22. Here, you will have to multiply what? Top and bottom by 31, right?
Yeah.
Now we're in business because you're referring to the same denominator. So you're saying, which is bigger? How do I know? Anyone calculate it? Actually, I know.
What would be the
295.
Right, are you going to compare or are you going to do it here? No. Get to work. You have to decide which is bigger.
27 times 22.
596.
But because you compare, right? This is, what is this? This is what?
22. 27 times 22.
594.
I know, and what is this number?
594.
594. This is
558.
50. Right. So this is big. Okay? Now, I'll come back and say something about this in a minute, but you see how you compare. So given two numbers, right, you just carry it through. The philosophy is, I don't ever want to deal with numbers, two fractions with different denominators. I put them on equal footing right away. And once you do that, you just examine what the numerators are. Which one is bigger? Who do you care? I mean, just whoever is bigger is bigger. Right? So this is bigger, so this is bigger. Right? So the whole fraction is bigger. So that's your conclusion. But in general, right? So let's phrase it the same way. Out of this, which is bigger? Well, all right. You have seen this. All right. You do it together. Let's do it together, right? What do I do? Faced with the task of comparing these two things,
Right.
what's the first thing I want to do?
Make them
Okay? See, you're getting it, right? Right? So this is equal to this if what?
ML.
ML? Right? This is the same as this. And this would be equal to this if we do
KN.
alright? And K? KN, yes, same thing. Okay, good. Then you say what? Depends on which is bigger. If this is bigger than this, then this is bigger than this. If this is less than this, then this is less than this. Which of course both are saying the same thing. So my conclusion therefore is that if ML is less than MK, then MN is less than KL. By the way, suppose ML is equal to NK. What's the conclusion?
3.
M over N is equal to
Of course, right? Because this is equal to this.
Right.
This is equal to this. And this, when you rewrite them in this format, they turn out to be the same fraction. It then says what? They are the same fraction in the first place. So that's right? Now, of course, don't want to write it down. You can see so-called, so to speak, if I say if
Oh.
do you believe it? Now this, I want you to tell me very carefully why it's true. I want every single little bit of detail to explain this. You'll see in a minute why. I'm reversing conclusion and assumption. In mathematical parlance, this is called the what? Converse of that one. Converse. Meaning here, this is here, in this position, this statement is what we assume to be true. And this is our conclusion. But in this statement, the same statement here is not what you assume, but rather what you want to conclude. You want to conclude this? What assumption do you make? You make that assumption. Well, that assumption was your conclusion. So you are switching roles. Doesn't happen often that when you switch, both are correct. So, a lot. If it rains, I carry an umbrella. Right? The assumption is it rains. Conclusion, carries an umbrella. What's the converse? Is that true?
No.
No. Right? Carry an umbrella. In Asia, you carry an umbrella when the sun is too strong. You know that. Oh, you wonder why the Asians have such good skins. It's true. I used to carry an umbrella. But so I just want to tell you the converse is usually not true. Right? I carry an umbrella doesn't mean it rains. But if it rains, you better carry an umbrella. So the converse is not always true. Right? In this case, you're in a happy circumstance that the statement and its converse are both true. Sometimes it happens. Pythagorean theorem, which we'll come to later, is the same thing. Right? So, knowing that, so you know more or less that it's going to be true. Why is it true? You start with this, right? Then this.
So the denominator is the same.
So then you say this. So yes, good, right? If this is true, right? Now you go through the same philosophy and say, I don't like things with different denominators. I insist. So I get this and that. So this is the same as this. You see that, right? So to say that this is less than that is the same as what?
Yeah, that's right.
Right?
Yeah.
Good. Now how does it follow that NL is less than NK? Why? So you're going by automatic pilot at this point. You already know it's true, and it looks so enticing, you just say, well, it's true. That's at some point it will be what you do. But we're at the beginning, right? So your charges, your students, they're grouping, they're learning at this point. You better leave no stone unturned. Make sure that you pin down everything exactly for them. So to say this is to the right of this, what does it mean? So what are these fractions? These fractions are obtained how? By counting to the right, fixed number of a certain number of steps of a fixed unit. This is called unit fraction. That's very simple. 1 over NL. You will take something this long, 1 over NL. You will get these fractions by counting to the right how many steps?
ML or NK.
So I know this is already to the right, correct? To this?
Exactly.
That means you have to go what? More steps to get here, then getting here. Let me repeat, right? I now know this fraction is to the left of this, right? So let's. Right? This is to the left of this. I know that. And these fractions are obtained how? By starting with that segment, which is 1 over NL, and counting to the right. Then. How many steps? To get here, I have to count NK steps. To get here, I immediately have to count NL steps. But all I know is that it takes me to count NK steps to get to the right of the one I obtained by counting only NL steps. So what does it say? That means you have to count more to get past this one, no? You have to count more steps than this one. Okay?
Isn't it the definition of a fraction? And you can think of if the denominator is the distance, a sequence, and each one is either equal. So if you have more of equal sections, it's going to be more than, or to the right of. If you have less than, so couldn't you use a definition of a fraction as proof of why that's true?
I don't see how.
Well, if you say the collection of all the sequences, that's to start off with the definition of a fraction, and all the sequences are equal, right? Equivalent. That's what we talked about. Sequence, segment, sequence. Segments are equal. So if we have equal segments, but more of the equal segments, that's going to be a larger, or to the right.
That's exactly what we're saying now.
Okay.
That's exactly what we're saying now. Yes. But you wouldn't say that's a definition. The definition means by that you don't have to do anything.
Okay, so you could not say my proof therefore would be because the definition
No, you cannot say that.
says.
You cannot say that.
Okay.
Because you have to understand exactly what the definition says.
Well, the definition is saying that the denominator is an equal unit. And if I have more of those equal units,
Yes.
then I have a.
So I'm saying now, I have, you're counting how many of these? That's what it says. You're counting how many of these? You count a certain number of steps, you stop here. You count some other steps to get to here. So we're comparing which is to the left of which. What? You know this is to the left of this, that means what? You have to count more steps to get here than getting here.
Or in the sequence, it comes before in the sequence we're talking about. I'm just going back to the definition, the collection of the sequence of. So that's what I was thinking. Oh yeah.
This is the sequence.
We're going in order.
No, that's exactly what I'm saying. This is the sequence of 1 over NL.
Right.
Right? So that's what it is. So the second number is what? You keep counting like this. The first one is 1 over NL. What's the second one?
2.
Exactly, 2 over NL. Third one is
3.
And so on. And that's why when the numerator gets bigger, you're going to get further to the right. And that's what you're trying to say, yes. Yes. But don't say by definition that's it, because you have to actually get into the details and say that's what's happening. Right? Now I do this. It does not mean that every time you teach, you spend all that time fixing this. For young kids, second graders, third graders, you probably don't even want to do that. Because you do that, I think for a second grader, for example, you insist on such great details, that's impossible. Like Glenn would tell me when I'm making it up. But for second graders, they're not at a stage where they worry about so many things. So you have to. That's what the teacher is supposed to do. You exercise judgment as to how much you want to give out. You cannot just dump everything you know on the kids. On the other hand, I have to make you go through this, why that? But you're the teacher. If you're the teacher, it's not 100% clear in your own mind how you teach. You're going to make mistakes. So when it's totally clear in your mind, then you can afford not to insist on too many details. You know at some point, when the time is appropriate, you can do it. when you're called upon to do it. Rich people are not always the best dressed, don't always have the biggest cars. So, same thing. When you have something, don't have to show it off. Yeah. Yes.
I wish I would have known this when I just taught third grade. This was the first year I've ever taught third grade. And we talk about comparing fractions, we talk about equivalent fractions, and we use models, and they use models, and they can see it visually, but once they step away from that, they lose it, it's gone.
Yeah.
And so being able to connect it with the number line that goes with them throughout their academic career, I think can start as early as third grade. Connecting it all to that number line is amazing and a powerful tool, I think, for them too.
And you could even do like just simple things like what you were saying, like kind of abstract things with not like as complex as that, but just doing two numbers and saying which one would be greater. If, just an N and an L or something. So that to see that they understand that the concept of the one to the left is going to be
That's
a
the key
smaller
point.
number. Yeah.
To drill it into their minds that they don't have to guess, they don't have to fantasize what's meant by big or little.
Yeah.
Just look at the number line, which is left, and that's the smaller one. That's very important.
Right, and it doesn't matter that you don't know what those two numbers are.
Exactly.
You would know that this one is.
Well, and
Yeah.
even for the littler kids too, the way you walk, you go one step
Exactly. That's-
further,
yeah.
so that number
Yeah.
is, I think
It's
that's
actually
great,
wonderful
yeah.
when they talk about you
Right.
walk like this and how many steps you have to
Yeah.
take. You walk further to the right, well then you take more steps. It comes down to that.
Yeah.
But you have to make them aware of it. Okay? This is wonderful, except that of course, I think we might have to do without the further homework assignment. That's it.
That's fine. We can all go to bed early tonight.
Get done.